This is Dr. Holt. Tonight I have a problem. I have a 150 kilogram mass sitting on, at this point right here, is sitting on a frictionless surface here. On top of that is a 40 kilogram mass sitting here. The 40 kilogram mass now is accelerating to the right at 4.5 meters per second squared, and the 150 is accelerating at 8 meters per second squared. So they have different accelerations. So if they have different accelerations, then we know that this object here is going to be moving. So it's moving relative to this because they have different accelerations. So it's going to be a kinetic friction right here. We'll start out drawing the free body diagram of just this piece right here, the 40 kilogram, right through here. All right. To do that, we come over here. We'll do a single point. I will draw a vector coming down, the force of gravity coming down, and we will take 40 times 9.8, and that will give us 392 newtons. And that would be the force of gravity. Now going back up will be our normal force. Now our normal force is going to be the force that the 150 is pushing back up. So we'll call that force normal, and I like to do 150/40, meaning the 150 is pushing back on the 40, and we will give that value also 392 newtons because we know the object is not accelerating down or accelerating up. Now if the object's accelerating right, we have to have a force, or net force, going to the right, and that force, the only thing it can be is friction, and we'll call that our kinetic friction. And we will just put it just like that. And then what I like to do off to the side or down below, I like to put the mass times acceleration. Now this is not really part of the free body diagram, but I think it helps you solve the problem. We put 40. We go ahead and multiply it by the acceleration, 4.5. And now what we can do is we can go ahead and sum our forces in the x direction. We're going to have the x direction going this way. Anything to the right is positive. So I'll say the summation of forces in the x direction must equal to mass times acceleration in the x direction. Again, anything goes right will be positive. That's going to give me Fk is equal to mass times acceleration, or 40 times 4.5. Now 40 times 4.5 is going to give me a value of 180 newtons. Okay, then we know this value up here is going to be the 180 newtons. Now one thing I would note, this kinetic friction, that is being caused by the 150 newton force. Not the 140, excuse me, the 150 kilogram mass. So this is the 150/40, meaning the 150 is creating this. So we will have a force pair when we draw the 150 going back, when we draw the free body diagram, the 150 going back the other way. So I like to put a slash through it like that. Now I'll come back down and we will draw the free body diagram of the 150. Now right before I do that, I can go ahead and state right here, this 180 right here is going to be the frictional force exerted by the 150 kilogram mass on the 40, and we can just put that as 180 newtons. And that's the answer to the first one. I'll do that in red. Alright, now we'll go back. Now let's do the free body diagram of the 150. Now I'm going to have a force coming down here. I'm going to have one more force pair, meaning when I did the 150 onto the 40, now let's do that in blue so we don't get confused with the other one. This right here will be the force of the 40 onto the 150, and that's going to equal to 392 newtons. Now the other force is going to be the force of gravity on the 150. Put it down there, and we take 150 times 9.8, and that's going to give me a value of 1470 newtons. Okay, now we'll have the normal force of the surface or the ground pushing back on the 150. And I like to call that F normal. And we can call that ground or surface, whatever you like, onto the 150. and that's going to equal to the summation of these two. Now you could just do the summation of the forces in the y, set equal to mass times acceleration, but you know the acceleration in the y direction is 0, so you'll just get the summation of those two forces. So 1470 plus 392 is going to give me a normal force of 1862 newtons. Okay, now as I stated, these are force pairs here and here. Alright, now let's go ahead and do this one. We have 180 here, so we'll have to have a force pair going back here of 180 newtons. And we'll do that with a red. And that's going to be kinetic friction. And again, that would be 40, I'll do it on here, hopefully you can read it, 40 onto the 150, and that's going to equal to 180 newtons. Now if you had a frictional force here, in this case it's a frictionless, if you did have frictional force, then you have another force going back to the right. So now what we can do is we can make this our F value. And again, what I like to do down below or to the side is go ahead and put the mass times acceleration, because it's important not to forget that. So we'll make this 150 times my acceleration, in this case is 8. Alright, now the question it was asking us here is, what is the net force acting on the 150? Well, it has to be, the net force has to be mass times acceleration, because the summation of forces in the x direction must equal mass times acceleration. So we know right now 150 times 8 will be our net force. That is not the value of F, but it's our net force. So we can make that into 1200 newtons here. Alright. Now we can go back and we're going to solve for F. So to do that, I say the summation of forces in the x must equal to mass times acceleration in the x. I will get minus 180 going back this way, plus F must equal to 150 times 8, and we already know that's going to be 1200. So we know F is going to equal to 1,380 newtons. So we can go ahead and put that in as 1,380 newtons. Alright, I hope we got one more question to answer, but I hope by me going through this you understand the importance of drawing very complete free body diagrams and identifying your force pairs, and again make sure they go opposite direction between each object. The last question says, after the 40 kilogram mass falls off the 150 kilogram mass with acceleration of 150. Well, if it falls off, this force here, the frictional force, is going to disappear. F would remain the same. Get rid of this. So all I'd have to do is say the summation of forces in the x direction must equal to mass times acceleration in the x direction. I would only have one force here, which would be 1380 is equal to 150 times A. We will solve for A 1380 divided by 150, and that's going to give us a new acceleration of 9.2 meters per second squared. I'll come back here and write that down as 9 meters per second squared. Okay, and again, that's all there is to this problem. It's really not that difficult if you draw good free body diagrams of each object. Anyway, I hope this video was useful.